Hey everybody, Rudy from IMC here to teach you about using dictionaries in Python in this episode. So a dictionary it's another kind of container data structure, right? So it's a structure that we can put other elements inside, but it's a bit different to a list. It's a little bit more specific. So whereas a list is sort of just an arbitrary, toss all my stuff in here, kind of like a big bucket, a dictionary is a set of keys that map to a set of values. Okay, if you're coming from a mathematics background, it's a lot like a function. But what that sort of means is if you have a particular key in your dictionary, one of the keys, you can very easily go from the key to its value, right? It maps the key to the value. That's all a little bit abstract. Let's just show you an example. So the syntax for a dictionary in Python is the curly braces. Okay, so if I look at what D is here, you see it's a dict in Python, right? Short for dictionary. Now this is an empty dict, not very interesting. Let's put some values and some keys and values in it. So the syntax is key colon value, and then you can comma separate to put more in. So this dictionary is a little bit more interesting now because I've got three sort of key value pairs. Okay, so in a dictionary, these things always come in pairs. Okay, and this is the key, and this is its corresponding value. This is the key, and this is its corresponding value. Okay, now as I said, the useful part about a dictionary is that if you know the key, you can go directly to the value, right? And the syntax for this, just to show an example, very similar to how we accessed elements out of a list, right? Except instead of accessing them by their position in the list, so 0, 1, 2, 3, we're accessing them by their key directly. So if I try and access this value, right, I get the 1, because if I look up A in the dictionary, there's a 1 there. Similarly for B, whoops, I've deleted my quote. Oh my goodness. And then similarly for C, right? We've got 3 as well. So that's a dictionary there. That's how we get elements out of it. Now the other thing we can do is, of course, we can add more elements to the dictionary. Okay, so let's say I want to add a Z key now. Very hopefully intuitive syntax, right? D of whatever key we want here is now this value, right? So this adds the key value pair Z4 to the dictionary. So if we look at the dictionary after having done this, you can see that right at the end now, we've got an extra key value pair, Z4 or Z4. So cool, so that's adding and accessing. Now something interesting here to note, right? So if I just get rid of this, let's go back to our starting state here. One thing you'll see is that if I can only ever have one value sort of for each key. So what I mean by that, oh, excuse me. What I mean by that is that if I try and now add a new key, A is 5, okay? Look at what happens to my dictionary. So normally it's 1, 2, 3. Look at this, right? So A is now pointing at 5, right? So when you do something like this in a dictionary, okay, you can only ever have one key you can only ever have one A key, right? Each key has to be unique and it points to one value. So if you try and do something like this, you override the previous value in the dictionary. Okay. Now, if I add my Z key back in again, right? Be careful because this only applies to the key side, right? So I've already got a 1 here, right? A points to 1. If I try and point Z at 1, oh, whoops, sorry, I should get rid of that extra A line. Right, so A is still 1 at this point. If I try and add Z as 1, Python's happy with that, right? Because the key is unique. So even though they're both mapping to 1, right? That's fine, we don't have to worry about that. That sort of functions separately. Okay, so just be aware of that. Another thing we can do with our dictionary, there'll be a little bit to go through here, is we can check whether a key exists in the dictionary. And the way you do that is actually incredibly simple. One of the things I really love about Python, you literally just get your key and you check if it is in the dictionary. It's as simple as that, right? So if I pick some key that's not in there, if I pick D or Z, right? Because I haven't re-added my Z back in, and I go, is Z in D? Gives me a false. Okay, so true, false, and of course, since this is just giving you back a Boolean value, you can use that with a if statement, right? If Z and D do something, or vice versa. Incidentally, with the in key, right, we can also actually do the opposite of in. So we can check, is A in D? Yes. And we can check, is A not in D, right? Notice how I've got these keywords here. False. So is A not in the dictionary? No, it is in the dictionary. Cool. I'll say final thing that we probably want to have a look at is that you can loop over a dictionary in Python. Okay. Now the way we sort of do that with a for loop is if you go for something in D, right? If I have some variable here, this variable will end up being the key as you loop through the dictionary. Okay, so if I just go, here's my dictionary, for loop over the dictionary and print as we go, you can see it's just getting the keys, right? A, B, C. Okay. Of course, if we have the key, right, we know how to access the value from that key. It's just the square brackets, right? So D of key, and you can see that's how we can get the values out that way, right? There is an extra little trick you can do here, which is if you ever need both the key and the value, right, which is often the case when you're looping over a dictionary, you can do something a bit special. So I'm just going to set up another loop here. Now the dictionary has a method called items, right? You can put .items on the end, and this allows you to loop over not just the key, but the key and value at the same time. So if you look at what happens when I print the second time here, right, you can see that the second loop is printing a sort of pair of values, right? The key and the value, okay? This data structure here is called a tuple, T-U-P-L-E. It's not super important for the moment, but what is important is we have the key and the value here. And so what you can do is you can actually go a little step further with Python, right? And you can, instead of telling it to give you one variable in the for loop, you can get a bit tricky and you can say, hey, I know that this items thing is going to give me back pairs. So here's one variable and here's another variable. And then Python is smart enough to sort of unpack those for you and give you them separately. So if we look at this now, look at that. These two guys are doing the exact same thing. Okay, so that's our normal for loop over the key, and this is our for loop over items, which gives us a key value pair. Super useful. Now, that's pretty much all we're going to need dictionary-wise. So, yep, with that being said, I'm going to head on over because it is Terry time. That's right, everybody, Terry time. So, let's have a read. Emboldened by his banana trading success, Terry has decided to expand his empire to other produce at the markets. He now keeps a note on him which contains his estimation for what each product is worth. If he can buy a product for cheaper than his estimated price, he will. Right? Conservative Terry. If he doesn't have an estimation for a product, he will never buy it. Super conservative Terry. So we're going to write a function, should buy, which accepts 3 arguments. Okay? So we've got product, which is the name of the product, which is a string. We've got the price, which is the price of the product at the market, which is just going to be an integer. And then we've got a valuations dictionary of product to estimated price. So this is Terry's note that he's carrying around. Return true or false whether Terry should buy the product. Okay, so a bit of text there. It might be easier to look at the example, right? So basically we've got this. This is Terry's note, right? He's got product to how much he thinks it's worth as a dictionary. And then he goes, cool, should I buy a banana for $7 based on my valuation, right? And at this case we go, well, he thinks the banana is worth $8, so it's cheaper than he thinks it is, so he should buy it, right? True. The shell, he thinks it's worth $4, but this guy's trying to sell it to him for $6. Terry thinks that's a huge rort, so he says no. And then says, should we buy a plum for $3? And Terry looks at his note and goes, what's a plum? No, I'm not going to buy that. Okay. As always, encourage you to have a go with this using your new dictionary knowledge that we've just discussed. And so give me a pause. I will be back in just a few seconds with the solution. Okay, and we are back to help Terry with his growing trading empire. So I'm going to scroll down a bit, give us a little bit of room. So we need to write this should buy function here. Okay, so as always, I'm going to start off with our function definition. Should buy needs 3 arguments: product, price, and valuations. Cool. So what do we need to do? We need to have something like this as our valuations, and basically what we get is we get the product, we get the price, and we want to know if this price is cheaper than what this sort of key value is in the dictionary of valuations. Okay, so I guess what how do I want to start this? I think I kind of want to start by just seeing if, based on a product, let's print out what our valuation of that product is, right? So what do we think this product's worth? So this is our dictionary. This is our product in our dictionary. Okay. And for the moment, I'm just going to ignore this plum case. We'll get back to that. So let's just assume our product is in the dictionary. How do we get the value out of it? Well, remember this is a dictionary, so it's dictionary, and then we need to get the key. And the key for this particular set of dictionary, right, is it's product to price. So the product is the key. So this is our value, and let's just print that out, right? And now I'm gonna actually use some of this code down here to try running one of these, and let's just see how we go. So if we have our valuation that looks like this, and I call this with banana, right? All we should be doing at the moment is getting our valuation for a banana and printing it out. Which, based on this dictionary, we should hopefully just be printing an 8. Okay, cool. So there's our valuation. If I try this with the shell, we then get the 4, right? Because the shell valuation is 4. And for the coconut, we get 13. Okay. Of course, at the moment, if I try and do this for the plum, right? Our plum isn't in the dictionary, so we get an error, right? A key error. And the key error basically means this key isn't in my dictionary. Okay, so back to the banana. Now at this point, what do we actually want, right? We don't want to print the value, though I might leave that there for the moment, but we want to know if the value is cheaper than the price. Okay, so in other words, if the value is cheaper than the price, then we should buy, right? So we can return true. If the value is not cheaper than the price, we can return false. All right, seems reasonable. So let's check the $7 banana again. So if the, I've done this backwards. Whoops. If the price is cheaper than the value. Sorry. we want to buy low, sell high. Cool. I was like, that wasn't right. So if our price, so if he's trying to sell me the banana for $7 and it's cheaper than us because we think it's $8, then we will buy it. Otherwise we won't buy it. So at this point, we're actually almost done. Gonna get rid of that print statement. The only thing we're missing, right, is this plum guy, because at the moment this plum guy is going to explode. It's going to say, I don't know what a plum is. So we just need to add a little check before that basically goes, is this plum in our dictionary? Okay, now hopefully you remember how that worked. If, whoops, not plum, what are we looking at? Our key is the product. So if the product is not in our valuations, gotta love how much Python looks like English sometimes. If the product is not in the valuations, what do? Well, Terry never buys a product if he doesn't have an estimation for it. So should he buy it? No. No, he should not. Okay, and now if I try my plum one, we get a false. Okay, if I try this for coconut, should he buy a coconut for $7? Yes, he should, because it's super cheap. What, should he buy one for $50? No, he shouldn't. And should he buy a fish? No, he shouldn't. Okay, cool. One little trick I will show you here is this if statement. We can actually reduce it a little bit. So what we're really doing here is we're trying to really just return the value of this, right? So if price is less than value, then this is true. So we return true. If price is not less than value, then that means like this statement is false, right? And we return false. So you can actually replace all of this with just this value. So what do I mean by that is you can actually just, you can return price less than value, right? Because this statement here, this expression will give you back a true or a false. Oops, I left the colon on. And it'll work exactly the same way. So if I go back to using a banana, buy a banana at $6, right? What we return here is the expression 6 less than 8, which is true. So that's just a little nifty thing. If you ever find yourself with like an if statement and then return true, return false, you can sort of clean it up like that. But that's widening the nets for Terry. So let's go into part 2 of today's Terry saga. So as always, the story here is compelling, so let's get into it. Despite his best efforts to stick to his conservative trading scheme, Terry is dazzled by a mysterious vendor and persuaded to buy a mystery box containing a number of mixed products. That is not how you stick to your trading scheme, Terry. After his shameful moment of weakness, he is still keen to know the total value of each product he bought. So at least he's trying to recover. Write a function mystery box value which takes in 2 dictionaries. So a dictionary of product to number of stock. Okay, so sort of like an inventory here. And the valuations dictionary, which is the same dictionary. So a dictionary of product to estimated value, string to int. Cool. The function should return a new dictionary mapping each product to the total value of all stock for that product based on Terry's valuation. Okay, so let's look at the example down here. So if we've got a products dictionary that says we have 200 bananas, 300 shells, 100 coconuts in our giant mystery box, and Terry thinks that a banana's worth this much, a shell's worth this much, and a coconut's worth this much, then what do we end up with? We end up with so our mystery box value, right, is we had 200 bananas at $8, so we end up with $1,600 worth of banana. We end up with $1,200 worth of shells, and we end up with 100 times 13, $1,300 worth of coconuts. Cool. So I'm going to give you guys again, have a go at this one. For this one, you can always assume that the products and the valuations are going to line up, right? So what I mean by that is just assume that these guys always have the same keys, because otherwise it's kind of hard for Terry to make a valuation on something. So the mystery box, as mysterious as it is, okay, we do know the value of every product in there, okay? So have a go at it, pause me, and I'll be back in just a few seconds with the solution. Alrighty, let's have a look at Terry's mystery box here. So, mystery box, oh goodness, value takes in 2, I cannot type, products and valuations. Okay, where our products and our valuations look like, well, like this, right? So what do we need to do? We need to return a new dictionary mapping each product to the total value of all stock for that product. So we need a new dictionary, but maybe for starters, we're definitely going to need to look at each product in the mystery box. So for each product in the mystery box, we want to look at it, and then we need to find its valuation. So I'm just going to start off with a good old for loop. So we could do for key in products, but what I'm going to actually do is I'm going to call this guy product. because I think that makes a bit more sense, right? Because the key in our products is the product. Let's just always start off nice and simple with some prints. So I'm gonna steal these guys so I can run this a bit more easily. So let's see what we've got so far. So for product in products, cool. We printed banana and then shell and then coconut. So that's nice. Now, if we want to know the number of stock we have for each product, okay, then we can get that out of our dictionary, right? So products of product, right? Because this is our products dictionary. Oh, sorry, this is our products, which we're passing in. And then we have the product banana, shell, coconut. So now we should hopefully get 200, 300, 100 if I choose to print that out. So let's print the product and the stock. Yep, so banana 200, shell 300, coconut 100. Alrighty. Now the other thing we need before we can sort of keep going is we need the price of each product, or the valuation of each product, I suppose, the value. Now the value comes out of the valuations dictionary. But the valuations dictionary has the same key, right? So for each product, we want to go, what is this product worth? Okay, so the value, gonna have some very similar code here, right? But it's our valuations guy, keyed by the product. So whatever product we happen to be looking at, get how much stock it has from the products dictionary. Get its value from the valuations dictionary. Okay, oops, I need a comma there. And now if we look at this, you can see we've almost got all our bits and pieces here, right? We've got the banana. The banana is 200 and it is worth $8, right? The shell, we have 300 shells and they're worth $4. And the coconut, we have 100 coconuts and they are worth $13. All right, so that's nice. So I guess the final thing we want is, what we really want is we want to know the total value, right? So 200 times $8. So the stock times the value is really what we're interested in. So let's just replace this with a stock times value. Cool, and this is starting to look really nice, right? It's starting to look pretty close to what we're trying to get out. We have $1,600 worth of banana, $1,200 worth of shell, $1,300 worth of coconut. And now our final thing is we're supposed to return this in dictionary form, right? So we're going to need to make a new dictionary. So this is going to be our, I guess our total values, let's call it. Now remember to make the dictionary, braces, okay? And then what do we want to do? Instead of printing, we want to add the product as the key and the overall value as the value. Oh, that's convenient. So I'm going to get rid of this print and we're going to replace it with a dictionary add. So total values, and then we want to product equals, and then it's the stock times the value is our value for this product key. Okay, I think that looks right. So let's give that a run. Let's move this down a bit. And we got absolutely nothing back because I am an idiot and I forgot to return our total values from our function. So we just got nothing back. But let's have a look at that one. Boom. There is our answer that we've been looking for. So remember, making a dictionary, empty braces, adding new values to a dictionary just looks like getting it, but then you assign it to something else. Okay. So that's dictionaries, all the sort of important things that we touched there. So dictionary, getting elements out of a dictionary, assigning new elements into a dictionary, for looping over a dictionary, right? Remember, you for loop over it, you get its keys out. And of course, we also had, in the previous example, we had you can check if stuff's in a dictionary. Now, there are a lot of other things you can do with the dictionary. But certainly this is sort of covering really the main uses of it. I've been Rudy from IMC, and I will catch you guys in the next part of the tutorial.